Hello students, welcome to the second session which is specially made for Chetna's group tuitions, and this session will help us complete the chapter of refraction from the theory point of view. So in session 1 we had done the starting part of refraction. Today I am going to continue with the chapter refraction of light. Now in this chapter and in this part, today's session, the questions what come in that page number, I have put a button so that you can identify which page number, which question will come. And if you notice the first question, page number 76, and the question is, why do stars appear higher than they actually are? Why do stars appear higher than they actually are? And the diagram, if you see, there is one star, there is a person looking at the star, and this is the star and this is the apparent position of a star. So if you see apparent position of a star, it is higher than the actual star. Why does this happen? Answer is simple. Answer is when star light comes towards Earth, it is coming from vacuum towards our atmosphere. That means light is traveling from rarer medium to a denser medium. Light is traveling from a rarer medium to a denser medium. In that case, light will bend towards the normal. Light will bend towards the normal. And if light bends towards the normal, we feel that the star has gone higher. Therefore, to answer the question in one simple line, the answer will be as follows. When star light comes from the star to the Earth, it is traveling from rarer medium to a denser medium. Hence, it bends towards the normal. Therefore, the star appears higher, and the star also appears twinkling, sparkling, because star is so far, it is taken as a point. And because of changes in our atmosphere and the gases, we feel that the star is twinkling. Now, when we make this statement, the next question that comes to your mind is, if you see a star, it will be twinkling. But if you see planets, planets do not twinkle, but stars twinkle in the night sky. Therefore, whenever you see the night sky, when you see so many stars, many people will tell you that is Venus. How can they tell you? Because that is not sparkling, that is constant one point. Answer is, in one word, it is distance. Because planets are at a much nearer distance compared to the stars. And that is why I cannot take them as a single point source. I have to take them as a large collection of points. Therefore, to answer your question in one word, why do planets not twinkle? Answer is distance, because planets are much more nearer compared to the stars. Now, the next topic is called dispersion. You might have heard of the word disperse. You know what is the word disperse? You have a group, and if your teacher says disperse, means all of you go. Correct? Similarly, white light, when it goes into the prism, it will disperse. Disperse means always scattering, spreading. Therefore, if you look at this diagram, which you have seen many times in the past, you have a glass prism, you have a sunlight. Now remember, sometimes they'll confuse you by saying white light. Now remember, sunlight and white light is the same. In other words, sunlight is our white light. And what is the definition of dispersion? The definition of dispersion is splitting of white light into its 7 constituent colors is called as dispersion of light. So when white light passes through the prism, it will spread into its 7 colors: VIBGYOR, violet, indigo, blue, green, yellow, orange, red, with violet being the most dispersed or most bent and red being the least. It depends on the wavelength, but don't make the mistake of writing VIBGYOR this way. VIBGYOR has to be written from bottom to the top. VIBGYOR. Therefore, let me repeat the definition of dispersion of light. Splitting of white light or separation of white light into its 7 constituent colors is called as dispersion of light. When you hold a scale near your eyes, you can see the 7 colors. It is exactly in this order. By scale, it has to be plastic scale, because remember, in this chapter we are talking about transparent medium. Okay. Now the next topic, which is the examiner's favorite topic. In the exam you will definitely get 1 or 2 questions based on this, is partial reflection, total internal reflection. And in this topic we have something very important called critical angle. Very simple to understand, but one thing you please make a note in this topic. This topic is called partial and total internal reflection, page number 78. What you need to understand is, in this examples, partial, total internal, critical angle, light has to travel from heavier medium to a lighter medium. Means light has to travel from a denser medium to a rarer medium. Light has to travel from a denser medium to a rarer medium. So let me take one example of light going from water to air. Remember, in this case, light is originating from the denser medium and going towards the rarer medium. Therefore, let me take water and air. Last class, in my last session, I had told you when the light is exactly normal to any surface, there is no refraction happening. Therefore, can I say this case, if it is projected normally, there will not be any refraction. Now let me increase the angle of incidence. If I increase the angle of incidence, there is some refraction and some reflection. Increase the angle of incidence even more. Increase the angle of incidence even more. At one point you will see the angle of refraction becomes 90 degree. What will you see? At a certain angle of incidence, my angle of refraction becomes 90 degree. In that case, my angle of incidence is called critical angle. Now the exam question will be, give me 2 conditions for critical angle to take place, or what are the 2 conditions required for critical angle. The first condition is that light has to travel from denser medium to a rarer medium, and the second condition is angle of refraction in the rarer medium. Angle of refraction in the rarer medium has to be 90 degree. These are the 2 conditions for critical angle. Now what if I increase the angle even more? Means my angle of incidence will be even more than the critical angle. Then what will happen? Then if I increase the angle more, then all the light will come back into the same medium. That means if my angle of incidence is greater than the critical angle, all my light will come back to the same medium. This is called total internal reflection. This is called total internal reflection, TIR. Now the exam question is, what are the 2 conditions required for total internal reflection? Now the 2 conditions required for total internal reflection are, first, light has to travel from denser medium to a rarer medium, which you know. Same for critical angle. And the second condition is my angle of incidence should be greater than the critical angle. My angle of incidence should be greater than the critical angle. Now this is all about total internal reflection. Now brilliance of a diamond, sparkling of a diamond, any question like that which comes in the exam to do with diamond, 99% of the time answer is because of total internal reflection, diamond appears sparkling or shining. Now we have studied 3 major concepts. If you think about it, one is refraction, one is what we studied, dispersion, and one more that we studied right now, total internal reflection. What if I can use all 3 concepts in one single phenomena? Which 3? Refraction, dispersion, total internal reflection. If I combine all 3 into a single phenomena, that becomes my rainbow. Now rainbow uses all 3, combination of dispersion, refraction, total internal reflection. Page number 78 in your textbook. Now for rainbow to occur, remember one thing, sunlight should be behind the observer and the raindrop should be in front of the observer. Raindrop will act like a small prism which will give the light in this way. Remember, even rainbow is Vibgyor. Even rainbow is Vibgyor. In rainbow, this prism is played by the raindrop. Therefore, what is the condition for the rainbow? Condition for the rainbow is the sunlight should be behind the observer and the raindrops should be in front of the observer. And which phenomenon does rainbow use? Rainbow uses all three phenomena. That is dispersion, refraction, total internal reflection. And you might be surprised to know the shape of a rainbow is not semicircle or not an arc. The shape is a complete circle. But since we are at a very low level, we can see only a part of the rainbow. Now this completes the theory part and this completes session 2, which was made exclusively for Chetna's group tuitions. We will continue with session 3. Thank you for watching. Bye-bye.